In today's lesson, section 7.3, we are going to learn how to multiply radical expressions. Let's start off looking at the square root of 9 times the square root of 4. One way to solve this is to find the square root of 9, which is 3, the square root of 4 is 2, and finally 3 times 2 is equal to 6. An alternate method for solving would be to take the square root of 9 times 4, multiply the numbers together on the inside. We'll see that these are the same because 9 times 4 is 36, and the square root of 36 is also 6. Therefore, the square root of 9 times the square root of 4 separately is the same thing as the square root of 9 times 4 altogether. Let's try this for a cubed root. Let's say we have the cubed root of 27 times the cubed root of 8. The cubed root of 27 is 3, the cubed root of 8 is 2, so again we are left with 3 times 2, which is equal to 6. If we were to put the multiplication together, underneath the cubed root, we have 27 times 8 on the inside. You can grab your calculator for this one to see that 27 times 8 is equal to 216. The cubed root of 216 is 6. So we see that we get the same answer. Therefore, cubed root of 27 times the cubed root of 8 separately is the same thing as doing the cubed root of the two being multiplied together. So this leads us to a rule that we can use for multiplying radical expressions. I just recorded an Algebra 2 lesson that was about rational expressions. Ours is radical expressions. So here's our rule. Suppose we have the nth root of A times the nth root of B. These roots have to be the same. We call this number the index. So either both square roots, both cubed roots, both fourth roots, and so on. It's the same thing as the nth root, keep the index the same, of A times B. So let's try this rule on a few problems. Suppose we wanted to do the square root of 3 times the square root of 10. This would be equal to the square root of 3 times 10, which gives us the square root of 30. The cubed root of 2x times the cubed root of 13y is the same thing as the cubed root of 2x times 13y. In this next one, let's look at the fifth root of 2 over a times the fifth root of ba over 3. When we multiply the insides, we are left with 2ba over 3a. Since we have a common factor of a on the top and the bottom, we can actually cancel that, giving us a final simplified answer of the fifth root of 2b over 3. Now notice that this is a square root times a square root. Altogether it stays as a square root. Cubed root, cubed root, cubed. Fifth root, fifth root, fifth root. So the type of root is going to stay the same. Next, we are going to look at simplifying radicals. Starting with the square root of 50, we can split this into the square root of 25 times 2. Using the rule on the opposite page, kind of going backwards, that can be split into the square root of 25 separate from the square root of 2. Then the square root of 25 is just 5, so we write a 5 out in front of the square root of 2. Now, we specifically chose the factor of pair 25 times 2 because 25 is a perfect square number, and we were able to take the square root of it, getting it simplified down. There are other factor pairs that multiply to 50, for example, the square root of 5 times 10, but we cannot do the square root of 5 or the square root of 10, so it does not help us to get it simplified. We specifically are looking for factors that are perfect square numbers. Let's try this one. Next we have the square root of 18. Looking at the list of perfect squares, do you see a perfect square that is a factor of 18? Very good. 18 is the same as 9 times 2. So let's split that into the square root of 9 times the square root of 2, and our final answer we get 3 times the square root of 2. Let's try another one, bringing a variable into our radical expression. First, we need to think about splitting up the 40. Looking at our factors over here, possible perfect squares, 4 is a factor of 40, so we can split that into 4 times 10, and we still have our x squared on the end. Now 4 is a perfect square, and x squared is also a perfect square. So the square root of 4 is 2, the square root of x squared is x, so that goes out in front, and we're left with the square root of 10, which is left on the inside. Let's try one more, 36a to the 4th times b. 36 is already a perfect square number. For the variable part, a to the 4th, we can split this into a squared times a squared, keep the b on the end. We see that a squared is a perfect square, and so is the 36. When we think about bringing those out in front, the square root of 36 is 6. The square root of a squared is a. We have another one of those, and we're left with a b on the inside of our radical sign. Altogether, we have 6a squared in front times the square root of b. Now we are going to simplify some cubed roots of numbers. This time we're looking for factors of 24 that are perfect cubed numbers. Recall our list off to the side of perfect cubes. 8 is a factor of 24, so we can rewrite this as the cubed root of 8 times the cubed root of 3, because 8 times 3 equals 24. The cubed root of 8 is 2, and then that's just out in front of the cubed root of 3. How about the cubed root of 54? Going down our list, we see that 8 does not go into 54. 8 times 7 is 56. Looking at the next number, 27 times 2 is 54. So let's split it up. Cubed root of 27 times the cubed root of 2. The cubed root of 27 is 3, so we're going to put that in front of the cubed root of 2 that we're left with. Let's try one where we're adding a variable. Starting off with the 72, we can see that 8 is a factor of 72. 8 times 9 is 72. So let's split this into 8 times 9. And then looking at the variable part, the x to the 4th, we want to find a perfect cube inside of that. So we can split that up into x cubed times x. Altogether, this is the same as x to the 4th. Now let's highlight our perfect cubes, 8 and x cubed. So out in front, the cubed root of 8 is 2. The cubed root of x squared is x. The leftovers on the inside, we're left with the cubed root of 9x. One more cubed root. Looking at the 16 that we have out in front, 8 is a factor of 16. So let's split this into 8 times -2. And with the x to the 6th, we can split that into x to the 3rd times x to the 3rd. Altogether, this is x times x times x times x times x times x, so it is the same thing as x to the 6th. So we can highlight our perfect cubes that we're going to take out in front. The cubed root of 8 is 2. The cubed root of x cubed is x. The cubed root of the other x cubed is also x. And we're left with that -2 on the inside. Altogether, we can say this is 2x squared times the cubed root of -2. Now we are going to look at simplifying a couple of 4th roots. Off to the side here, I have listed 2 very common 4ths that you should memorize. 2 to the 4th is 16, and 3 to the 4th is 81. So looking at this next problem, splitting apart the inside, we already have a perfect 4th in the 81. Z to the 11th can be written as z to the 4th times z to the 4th times z to the 3rd. We are writing these as z to the 4th because those are perfect 4ths. Notice how 4 z's plus 4 z's and another 3 z make that up to 11 z's. Remember that we want to add the exponents, and it should equal 11. So I'm going to highlight the pieces that are perfect 4ths. The 4th root of 81 is 3. The 4th root of z to the 4th is z. Another z to the 4th is another z. And we're left with the 4th root of z cubed on the inside. Altogether, it's 3z squared times the 4th root of z cubed. Let's try one more 4th. The 4th root of 810 times x to the 9th. 81 is a factor of 810. 81 times 10. Inside of x to the 9th, we have some perfect 4ths, x to the 4th, another x to the 4th, and a single x left over on the end. Let's highlight our perfect 4ths and take those out in front. So the 4th root, 81, is 3. The 4th root of x to the 4th is x. Another 4th root of x to the 4th is x. And we're left, oops, not the cubed root, we're left with the 4th root of 10x on the inside. Altogether, 3x squared, fourth root of 10x. The final set of problems, we are going to bring the multiplying and simplifying together. In this last set, we will first multiply our radicals and then simplify the final answer. When we have a situation like this, where we have a number on the outside, we will start by multiplying those outside numbers. 3 times 4 gives us 12, and keep that number on the outside. Now we can multiply the insides of the radical. 2 times 10 is 20. X to the 5th times x squared is x to the 7th. Remember that we want to add our exponents when they are being multiplied and they have the same base. Now we are going to simplify this radical, square root of 20, x to the 7th. Using what we just learned, well, this is going back to a square root, we can split this into the square root of 4 times the square root of 5. And inside of x to the 7th, we have x squared 3 times. Those are all perfect squares. And then we have a single x left over. So perfect squares, 4x squared. We're going to bring that 12 down, keep it in front. We can evaluate. The square root of 4 is 2, so that's also going to go in front. And the square root of each of these x squares is going to equal x. X times x times x will end up being an x cubed, actually, out in front. And then the final pieces are leftovers. Square root of 5 times the square root of x. We're going to stay inside the radical as just the square root of 5x. Multiply all of the components together in front, giving us 24x cubed times the square root of 5x. Let's try this one. Now we're looking at multiplying and simplifying with fourth roots. We'll start by putting these together and multiplying the pieces on the inside. 20 times 4 is 80. A to the third times a squared. We need to add the exponents, so that's a to the 5th. And b to the 7th times b to the 5th, add the exponents again, giving us b to the 12th. Now thinking about fourth roots, we're looking for factors that are perfect fourths. Remember that 2 to the 4th is 16, and 3 to the 4th is 81. 81 is too big to be a factor of 80, but 16 is possible. If we do 80 divided by 16, you could use your calculator for that. We end up getting that it's equal to 5. So we can split fourth root of 80. Go ahead and split the 80 into 16 times 5. Now let's look for perfect fourths within our variables. A to the 5th is a to the 4th times a. And if we look at the exponent of 12, 12 is a multiple of 4, so 12 is also a perfect fourth. It's kind of like b to the 4th times b to the 4th times b to the 4th. So let's highlight our perfect fourths. And those are going to go on the outside of our radical sign. The fourth root of 16 is 2. The fourth root of a to the 4th is a. And the fourth root of b to the 12th is b to the 3rd. Remember, this was the same thing as b to the 4th times b to the 4th times b to the 4th. Take those fourth roots. B times b times b is b to the 3rd. Left over on the inside, and the fourth root of 5a. This is the last problem in today's lesson. We are going to multiply and simplify with fifth roots. Start by putting these together and multiplying the insides. x to the third times x to the third. Add the exponents, and we get x to the sixth. Notice how the quantity y plus z is the same for both radicals. Y plus z to the sixth times y plus z to the fourth. Same base, add the exponents, so it will be y plus z to the 10th. When we go to take the fifth root of this, we can split apart x to the sixth into x to the fifth times a single x. Y plus z to the 10th is already a perfect fifth because 10 is a multiple of 5. This is like y plus z to the fifth times y plus z to the fifth. So let's highlight the perfect fifths and take the fifth roots, bringing those numbers out in front. The fifth root of x to the fifth is x. The fifth root of y plus z to the 10th is y plus z squared. Remember, y plus z to the fifth times y plus z to the fifth. So do those fifth roots. We have y plus z times y plus z, making it y plus z squared. Left over on the inside, we have the fifth root of x. Thank you for watching my lesson on multiplying and simplifying radical expressions. Please do your best on the homework assignment, and if you have any additional questions, I will be available in class on block day to answer them for you. Thank you, and have a great day.